let's talk storage optimization here for a minute. So let me get on my soapbox for just a moment with the DuckDB thing. The difference between a duck lake and a normal data lake is how much database is actually being used. So the modern enterprise data lake stacks, they're using a database layer minimally just for the catalog, but not so much for seeking and streaming the data. So that's where Duck Lake sort of diverges from the norm. They've decided if you're going to bring the database back into the data lake world, you might as well bring it all the way back and put 100% of your metadata in it, because databases are really good. This is where all of your transactions are happening on the metadata layer. Now, the next part of that is what makes a Duck Lake or a data lake not a data warehouse, is that the data itself does not live in the database. It lives in an object store, which is a bunch of buckets. And so you can see we have a bunch of buckets here, and within each bucket we have a bunch of Parquet files, or these might be geotiffs too. If we are looking at this, our first thing is we want to organize this data as best we can so that it has rapid access for the use case. So maybe we optimize it for time, maybe we optimize it for space, maybe we try to do something with both. This is where Duck Lake accelerates again. It does have a time travel component built into it, because the way it versions the metadata, it tracks the changes. And those changes are tracked in files. And those files are periodically optimized. So if you have a, let's say, month or 6 months worth of changes, now you have a small files problem. You just vacuum that and you optimize it, and now you have a new set of files. But you didn't really have to create copies to do that. You can do it in place because your metadata layer is tracking everything. So you're really doing that in the database layer. And your Parquet files are being managed as immutable files, which makes them atomic, which really makes the database a crucial piece of the whole thing. So now we want to separate the data organization spatially. It has some similarities to files. So cloud optimized files, for example, those optimizations travel with the file. So a cloud optimized point cloud carries an octree in it. Geotiffs carry the overlay tiles, which is also another type of octree. But we don't have to stick with an octree. In fact, I'll show you that it breaks down when it comes to the data storage itself. So if we switch over to QGIS, these are equal area tiles. Excuse me. And we also have the option of hexagonal tiles. This is Uber's H3. These are not equal area, but they're very close. And then we have our traditional bounding box tiles, which is the least desired here, because most of our polygons in our metadata layer are in WGS84. They're in geographic coordinates. So if you make them fixed size, so they look good on the map, that translates to a file size problem, because your high latitude files are going to carry less data than your low latitude files. That makes it hard to compare particular tiles or particular bounding boxes here across the globe, or even next to each other in some cases. If you're dealing with a large area, like we are in some of these regions, so you can see there is enough of a latitudinal change where it could matter. So if you're just looking at a near equal area and you want to be interoperable with most of the industry, you would go with H3, and you would actually partition your object store so that you had in your buckets, which might be your regional polygons, you would have these partition strategies based off the tiles. And that means that when you go to access data, you're taking advantage of the metadata layer of the Parquet or GeoTIFF. If you're storing all of that in your database, which is what Duck Lake does, 100% of your metadata is in there. Then you get really rapid access and atomic commits, and your Parquet files get to remain as immutable. But these cells can be actual Parquet files, or they can be partitions of Parquet files. So it's scalable in that sense. Now, if you are interested in comparing tiles to tiles anywhere on the planet, then you really would want to lean into the A5 system, which guarantees you equal area. So it adjusts the angles of the lengths of each pentagon so that they all not just fit together, but offer an equal area. And that's the best of both worlds, really. So this is a way of partitioning or sharding the actual data itself. Now, what's in these tiles can be subgroups of folders and files too. But from a database perspective, being able to ask a database where in the object store we can find data for a given polygon, it doesn't really have to be a bunch of spatial joins or intersections. It can just be a lookup ID of a single cell ID, which is a one-column attribute. That really is the best of both worlds. And that's what enables a Duck Lake to be so much faster than some of the enterprise solutions that are out there.